Stoichiometry is using ratios between reactants and products in order to find the desired quantities. We can use it to find moles or grams or volumes or whatever the question is asked about. In this question, the first one, before reading the question, before doing anything, you have to check if the equation is already balanced. 1 nitrogen on the left side, 2 nitrogens on the right side, multiply this by 2, hydrogen 6 and 2 here, so we multiply it by 3. Now we have 6 and 6 hydrogens. Oxygen on the reactants is, we have 2 atoms, and 6 on the products, we can multiply this by 3. Now we have 6 and 6. Now we can read the question. If 824 grams of ammonia, directly while you're reading, underline the given information, underline it on the equation itself and write it underneath it. 284 grams of ammonia react how many moles of nitrogen oxide, circle the unknown and write X here. So the question is asking how many moles of nitrogen oxide are formed. We have to write the ratio in 2 steps. Step 1 from equation and step 2 from the question. Okay, step 1. There is 2 mole of ammonia that gives 1 mole of nitrogen oxide. This is given from the equation, from the balanced equation. That's why you have to balance it. Step 2 from the question. There is 824 grams from ammonia. We cannot write grams here. It is not allowed. So in order to solve this, use this law. Mole is mass over molar mass. Mass is 824 divided by molar mass of ammonia. Using periodic table, the number that is underneath the symbol. So nitrogen, 1 nitrogen, 14 plus 3 hydrogens, 3 times 1. The answer would be 48.4. Let me check the answer. Okay, then continue. 48.4 mole of ammonia gives X, we don't know. So this is the basic 2 steps. Then after that, cross multiplication, 2x, okay, 2x equals 48.4 times 1 divided by 2 by 2, or you can solve it using your calculator. The answer will be 24.2 mole, and this is the final answer. Okay, let's move to the next question. Before reading, check the balancing. Since there are coefficients here, means it is already balanced. How many, the question, how many grams of water? So is asking about water. Circle and write X. Produced 32 grams of methane, underline it. This is methane, CH4. Okay, so underline it and write 32 grams of methane. Okay, again, we cannot use grams in ratio. We have to convert it to mole. Moles is mass over molar mass. 32 is the mass divided by molar mass of methane using periodic table. Carbon is 12, so 12 plus 4 hydrogens, 4 times 1. The answer will be 32 divided by 16 equals 2 mole. Okay, 2 mole of methane. Now the ratio, step 1 and step 2. Step 1 from the question, between the underlined and the circled species. 1 mole of methane gives 2 mole of water, H2O. 2 mole of methane gives X. Cross multiplication, then x times 1, let me show it to you, x equals 4 mole of water, H2O. But the question is asking how many grams of water. So this is easy. Again, mole equals mass over molar mass. You can write it directly. Mole 4 equals mass unknown divided by molar mass of water 2 times hydrogen, so 2 times 1 plus oxygen is 16. So everything together, shift solve, mass will be 72 grams of water will be produced. So basically in ratios we cannot use grams, only moles. Move to the next question. This is a limiting and excess reactant question, just to determine which one is limiting, which one is excess. If we have two reactants and I'm asking to find how many moles of ammonia will be formed, which one should you use? The ratio, is it between hydrogen and ammonia or nitrogen and ammonia? You have to check the two ratios. So the first ratio is hydrogen and ammonia, the second ratio is nitrogen and ammonia. The one that gives me the smaller amount of ammonia is the limiting reactant. Okay, let's check the two ratios, hydrogen and ammonia, then nitrogen and ammonia. Step 1, step 2. From the equation, 3 gives 2, 6, step 2 from the question gives x. Let's write it for nitrogen. 1 gives 2, then step 2 from the question, 3 gives x. Cross multiplication, 3x equals 12, x equals 4 mole of ammonia, and on this side x equals 3 times 2, 6 mole of ammonia. So 4 is smaller. This means this is the correct answer and this is the incorrect answer. Smaller is the correct answer. What gives us the smaller amount? Hydrogen. So this means hydrogen is the limiting reactant. You can circle it, you can use it in any other ratio. And if hydrogen is the limiting reactant, this means nitrogen is the excess reactant. Okay. The last question is about the percentage yield. This equation is already balanced. Then 16 grams of aluminum, underline it directly on the equation, write 16 grams. Make sure that this is not allowed, you have to write it, you have to convert it to moles. React with excess oxygen, so there is no need to use oxygen here, producing 29 grams of aluminum oxide. What is the percentage yield? Since I'm asking about the percentage yield, this means I'm asking about the mass of the products. We have one product, so we have to use percentage yield, or we have to calculate the percentage yield of aluminum oxide. The grams that are given to us of the product will be the actual, even if it is not written. Keep this in your mind. This is the actual mass. That's why it's given. And we have to calculate the theoretical mass, or the mass out of calculations. Okay, let's do it. Again, we will do the ratio in 2 steps between the underlined and the circled one. 4 mole of aluminum gives 2 mole of aluminum oxide. 16 grams is not allowed, so we have to convert it. 16 divided by 27 is 0.6. Okay, So 0.6 gives x, cross multiplication, x will be, let me check it before, 0.3 mole of aluminum oxide. Since we're asking about the theoretical yield, so we have to convert this to mass. 0.3 equals mass divided by molar mass for aluminum, 2 times aluminum is 27 on periodic table, plus oxygen is 16, so 3 times 16. The mass using calculator will be 30 grams of aluminum oxide. This mass is called the theoretical mass because we calculated it. Okay, percentage yield is actual yield over theoretical. You can write it once. Actual over theoretical times 100. Actual was given to us 29 grams divided by theoretical, we did it right now, 30 grams times 100, and the final percentage yield answer will be 96.7, and this is our answer.